Okay, hello everyone, and welcome back to my podcast. Today's topic is AI adoption essentials and how you lay the groundwork for success in enterprises. And to do this, I'm joined today by Matt Hicks, who is the CEO of Red Hat. Welcome, Matt.
Hey, no, thanks for having me.
It's so lovely to have you with us. Where are you joining us from today?
From Boston, Massachusetts. We're getting a little chilly out here. Again, winter's almost on us. In
Yes,
Boston.
definitely. Yeah. So Gen AI has moved from obscurity of academia to the ubiquity of ChatGPT all in less than a year. But most enterprises have yet to put it into production. And you argue that this can be a good thing because you believe that moving too fast without knowing where you're going and why is not a good thing and rarely works. So Gen AI and AI in general have been the big buzzword now for over a year. But where do you feel that enterprises are today in terms of their adoption of artificial intelligence and in particular generative AI? Are they just at the beginning? Are they assessing it, or are they a bit further along? What are you seeing?
It's been surprising to me. I think almost every customer I talk to at this point is at least evaluating it, but also with some structure that I think is really healthy, where um, they're not taking the wild experiments on it. There are patterns where we're pretty confident that we know it will work.
Mm.
Even if you take Red Hat, uh, we're running one of the retrieval augmented generation patterns in production today on it, just helping us with support analysis. And a lot of companies I talk to, they know some of these patterns will work well, and they're actually further along than I would even expect. I've been in technology for a long time, and you sort of hit these trends that there's a lot of excitement, but then they're very hard to move forward. One of the reasons I think that is it's a good thing on this, I think it's built off a foundation of data science, machine learning, all of these iterations prior to this, which weren't necessarily that successful for enterprises, have built some discipline in terms of the data they have accessible. Maybe they did machine learning experiments that failed for them, but the change from doing that from scratch versus using a foundation or transformer model on it can yield better results with it. So it has been, I would say, almost every company I talk to is very early in the stages, but with a discipline about it that I think is going to lead them to success in production, which is that sort of durable success we look for.
Very good. Looking at the year ahead, then, do you expect enterprises to focus more on AI and or Gen AI or both of those?
I do. I think it's going to be one of the probably most significant investment areas, whether that's capital investment on infrastructure, hardware, or just people and time of where you put your energy, because it is changing so fast at this point. You have really significant camps of these massive models that are probably only going to run in cloud type environments that are really capable. But at the other side, you have what I think most users will see on Hugging Face, which is almost like if you're familiar with open source code and the storage of that on something like GitHub, Hugging Face is really becoming the equivalent of that for AI models. The amount of iteration, contribution, specialization of models that I'm seeing show up on Hugging Face and others, it's astounding to me. And so these are smaller models. They're more specialized. They're more fit for purpose. The reason I think we'll have that investment is going into next year, you have a lot of just architectural choices to make, patterns that you want to pick. We're obviously in the camp of we think open innovation wins, and it pulls a lot of brain power from every corner of the earth on it. But companies have to make that decision for themselves and then get into experimenting, and once you have winning experiments, putting them into production, and then refining them, because these things aren't a one and done deployment. You have to retrain them. You have to keep data up to date. So I think it's going to be a really an exciting year next year. The neat part for me is I don't think this will be a trend that falls away next year. I think from what I've experienced, it is capable enough that I think enterprises will see success point after success point and make it durable on it, versus just another technology trend that sort of withers away in the year.
And do you see any particular use cases or any specific areas of enterprises where you feel that this will be the focus for next year?
There are some that apply almost to any enterprise on the planet, which I would say in the case of being able to interact with customers or augment your own support teams, there's an external component of that for most companies. There's also an internal component of that if you think of how stretched HR teams are in global companies and being able to help them. That, for pretty much any modern enterprise, is a use case where, whether you're buying this from partners that embed the technology or leveraging it yourself, I think there'll be a lot of investment in it. Outside of that, you almost shift towards industry-specific areas of innovation. In automotive, we are absolutely going to see this evolving autonomous driving. And beyond autonomous driving, just ADAS, so driver's assistance capabilities. If you go into telecommunications, we'll see this affecting network traffic routing and those capabilities as they move to 5G. We see a tremendous push in factories and automation, and the models might be totally different. If you look at autonomous driving, it is obviously going to be vision-based on that, and we see a lot of vision models now built on this transformer pattern. But as you get into factories, it could be vision-based, it could be audio-based. There are a tremendous number of applications of these specialized models to apply. So I think we'll see it on some use cases that span the gamut, and then others that'll be very specialized per industry. And I was talking to you earlier about the article that you had read, and I think this is the key part of where partners come in, because you will have this domain expertise that gets added in those industry use cases that I think is really, really critical for companies.
Very good. And beyond factories, where does automation fit in terms of enterprise adoption of AI?
Yeah, if you look at changing the way we work, it's funny for me. I learned technology largely through open source and through books at the time. That's what was available. You read code and then you'd go read books, and that was sort of your knowledge base. As Google became more and more capable with that, and search engines in general, it really changed the automation behind programming. You could go find an answer without reading a book. One of the areas when I look at AI that absolutely will change the automation capabilities, not just of systems, but how we interact, is the ability to generate code. We've introduced capabilities with IBM around generating Ansible scripts to drive automation. I look at it as these are capable technologies. As with anything, there are pros and cons. You have to be careful with trademarks, copyrights, those capabilities. But models that are trained well, that you can trust, it is going to be lower the barrier to entry of expertise required to become really good. And I think that will speed up automation. I think I grew up in the IT side of the house. I think it'll reduce a lot of the toil that IT struggles with to let them tackle more exciting challenges like the AI ones we talked about before. So I think that is going to be it's almost in the known impact of how you use this to sort of augment, amplify your teams you have today.
Yeah, and you make the point around trust. So do you see that enterprises are trusting the existing foundation Gen AI models out there? Or do you do you see that enterprises want to have their custom models that is trained based on their own data?
That is, I think, the most challenging question for enterprise to decide. And I'll not to speak for a bunch of customers, but the patterns I've seen evolving, there are almost two areas that they look at. One is areas that they're not going to try to differentiate on as a company for it. In those cases, they need a enterprise trusted model, but they're not going to fine tune it, feed their own data, and try to refine it to them. They just want the efficiency of it. Similar to like that automation task. If you can help me build Ansible scripts, I may or may not differentiate on my Ansible script generation capability. But if you make a team of 1,000 sysadmins twice as good, that is worthwhile to me, just margins.
Mm.
That's the easier part, I think, for companies to look at because they can find a partner, a product, a tool capability to use. In the differentiated area, it gets a lot trickier for them because then the licensing of the model that they choose really counts, not just for 6 months for a POC, but for the next 5 or 10 years. It's going to be tied into their IP. Almost all of them, I would say, I struggle even using the term fine tuning, but they have the intent to augment those models with their own data, and they want to control the outcome of that. Because if that data differentiates them as a company, the model that they build it into needs to be their model on it at the end. They're not going to contribute that back. And I do think there's a lot of uncertainty for them right now of how do they do that and not have their IP bleed into models that their competitors have access to? What are those right choices? When we talk about open hybrid cloud and the importance of areas of being able to run AI in your own infrastructure, it's largely based on that, where you have your data in a place today where you trust it. If you're going to fine tune models, you have to know this is a model you control on infrastructure that you control so that it doesn't keep you from moving forward with those POCs. And that I think in the differentiating area for businesses, which is their most important area, I think that's where we're going to see a lot of the investment, thought, architecture put into really probably over the next few years on it to get that right.
Yeah, and you make the point that there's a risk that data can bleed into these models. So when you use open foundation models, the data that you put in can become part of future models. And then there are other big risks around copyright and licensing. So if you use a generic foundation model, there's a lot of legal wrangling going on at the moment. They're saying, has this been trained by data that has been authorized, that can be used, that there's no copyright infringement? So there's a risk for enterprises there. And I guess there's also a risk of the output that these models are generating. Who owns the copyright to this? So how can enterprises protect themselves from some of those risks?
I think it... in the proof of concept phase, I don't think many enterprises will think too deeply around this right at the start, just to test the capability, see what works, see what doesn't work. But then really quickly for us, you get into two phases of that. Do you trust the licensing of the model itself? I think we're from the world of open source code, which is, it is accessible to any human on the planet, which we love, and we drive contribution into that model. But they're also restricted by license terms on it. If I go back, almost 20 years, there was really the understanding of GPL licenses and how those might infringe on proprietary software models. You had to be very careful of what you mixed and didn't mix. Open AI models are not that much different in it, where they're very expensive to generate, and they usually have terms that restrict the usage. That's the first level, is making sure that the model you're using actually is something you can use for the long term. And then the second click below that, you touched on the if that model itself has been trained on data that's going to infringe on copyright or other licenses, you might not be able to use the output. And the classic example for that is if it's a code generator and it was trained on GPL code, if you are a proprietary software company, you probably cannot use the output of that GPL code in your product, or you will have to apply the GPL license to your software. Those are those nuances of really trusting your model producer on it, both in terms of the license and contract terms, but then also of the data origin with it. The neat part with this, and I'm an engineer at heart, so I play around and I experiment this with quite a bit. The models, when you get to some of these core categories, they're getting capable enough where you can switch and choose and pick and refine your model, even post POC for it. And so I think it does yield a good opportunity to understand if these experiments are right for you, if you have the skill set, if you can put them into practice, and then go through that second phase of saying, you know, this worked with me with the Llama 2 model. Is that the right model for my company on it in terms of terms, in terms of data, or do I go to a different, more specialized variant or something else? But that is when it's your IP on the line, that's the 5 and 10-year decision you have to get right. If you rush into that decision, those are the things I think that can be really challenging for customers if they don't think through that early, because it's harder to change the longer you go.
There are definitely some voices in the industry that say open source foundation models are risky. They're putting them out there. What's your view on this? I take it that you're in favor of having these foundation models and transformer models as open source systems.
Yeah, I think we know the argument. You know, let's be honest. 20 years ago, when open source code was coming around, we heard this same rhetoric, which was it's much more secure to have code that no one else can see, because then people can't see the security problems in it. And the open source mantra was always, well, they can't see the security problems, but like people that see them will also fix them. And having things with a lot of eyes on it will generally yield a better outcome. I don't think anything changes in this area. For me, I've noticed I gravitate to the models that have transparency, where I can see what they were trained on. I can see the data. It lets me build trust, not just in the data card description of it, but really seeing what they were built on. And I think in these new areas, that depth of trust is really critical. You know, in some of these cases, if you're betting your business on it, you probably just don't want to be betting on what the web page says. You want to be able to do your own diligence. And I think open source has always allowed that diligence at any level of depth. I think the same fundamentals hold to AI. There are some nuanced differences between the application of models and runtimes, but I think more holds in that model than changes in that model.
Very good. So for any organization that wants to start really well on their AI journey, what tips would you give them? What advice would you give them to say, these are the things you really need to have in place to succeed on this journey?
For us, I've had a bunch of these conversations where the first one is really understanding, do you want to differentiate or not on it? Because if you say, I just want efficiency for this, you have some pretty easy options and experiments that you can put into practice before the year is out on it. And that could be in Ansible or code generation. It could be in the retrieval augmented generation pattern that I mentioned about. Those are the fast and easy ones. If you then move into the, I want to lead, I want to be the tip of the spear and really put my business ahead, you have to understand the data, how you're going to structure it, and how you want to actually wield that data to your advantage with it. If you don't have the data structure in place, it is very hard to differentiate off a really capable chat model. You know, you're all of your competitors will have the same access to the same very capable chat. These are the paths where you get into fine tuning, you get into the combination of multiple models, how a Lang chain. That's the part that needs planning, but I would also argue that's the more exciting part for a lot of businesses too. We know this will work. Finding those partners that are going to help guide you through that, I think for most companies is pretty critical. Otherwise, they could just waste time in the experimentation phase. But whether that's in the SI areas, knowing where you're going to run models on this, I usually give the example of it's an important time to decide whether you will only need to run models in the public cloud or whether you're going to have to bring those models closer to your customer. For example, in a retail branch office or in a car or on a telephone pole or in a factory. And if that's your case, you are in hybrid cloud deployments and you really have to plan that. So I think understanding that and then picking your path will lead to really good outcomes for companies on it. But stumbling through that, I think there'll just be a lot of dead ends that companies will hit that they could avoid pretty easily.
Yeah, I completely agree with you. I think it's super important to think: do I want to differentiate myself? And suddenly proprietary data becomes so vital in this process. And beyond the technical element, there's a business perspective you need to take. You need to make sure that these applying Gen AI and these models are generating value to the organization. How do you make sure you link this to your business goals?
This has been a tricky one, and I think you touched on this in your last article of there's a human element to this as well. And I think with a lot of things, if you only focus on margin and you don't focus on the people aspect of this, you can hit other barriers in the process. I'll give you an example that we have gone through on our side, where when we start using these capabilities to improve our ability to do L1 and L2 support, we have a great path for associates because they can go deeper in their expertise now and help move their career to doing level 3 support or even move beyond that to engineering. So it's less of a, we don't need you, but we're removing that toil that is really undifferentiated to let associates progress their careers on it. And I think having that balance where you're really conscious up front about what are you trying to optimize? Is it good or bad for your associates? And culturally, like, how are you going to look at the outcomes? That's one really important aspect. The other aspect that I ask my teams every day on the cost of infrastructure right now, especially if you take NVIDIA, I would say is at a premium for this. You really have to be careful about the runtime costs of, is it more expensive or less expensive than what I currently do? Because you do need people in the loop. You do need to refine these. And you have to know whether you're willing to spend more in the short term and whether you can ever get to spending less in the long term. For us, that really came down to making choices that we could optimize infrastructure over time. So we needed to know the experiment worked. We needed to know we had our people expertise in the process. But I also had to have some comfort that over the long term, we could drive the query costs down to make this worthwhile on it. Those are the areas I think that, do we have the expertise to make the experiment work? To your point on the technology side, do we have the cultural structure set for this where teams don't feel disrupted or displaced, where they feel like this can be a good outcome for them? Because that helps everyone contribute. And then are we just moving people cost to compute cost and things get even more expensive? Or do we see this as a reduction in cost so we can invest more in our people on it? For me, at least, getting that balance right has been really important. I think that's a parallel that we'll see in a lot of enterprise leaders of, making sure that people aren't put out by this technology, but they see it as something positive to them as well.
Yeah, two interesting points you make here. One is the cultural element, and one is to make sure that you actually deliver the desired results. I'd like to touch on both of those. In
Sure.
terms of culture, how do you create the culture in your organization so you're ready to embrace AI?
Uh, for us, being a software company that's in open source, that always feels like it's moving 90 miles an hour, I do think it's been a little easier for us because I've been at Red Hat just over 18 years at this point. Every single one of those 18 years has been a shift in technology. And so our culture, like the bedrock of our culture, is you always have to be watching, learning, competing in this area to serve customers on it. AI is a big shift in it, but it's really no different. We've been through virtualization, we've been through containers, we've been through all of these large shifts. So it's a bit built into our DNA on it. I do think, though, that is a critical aspect for companies of you just have to decide, are you willing to put in the investment to learn on it? If, I've worked with a lot of IT shops where it is a model where they outsource everything goes to vendors. That's a harder gap to bridge, where you're counting on your vendors to go learn this new technology and bring it to you versus what you really want to have in-house. So for us, I think it's a little easier. We're in tech. Tech is always evolving quick. We tend to be excited with things like this and really leaning into it. But I can see the challenge in other companies where that might not be at the core of their work. They could be from really conservative industries where that could take a little more effort than it took me at Red Hat to push for.
I very much agree. And then in terms of the return on investment, we've seen so many other digital transformation efforts fail to deliver the returns that they promised. Will we see something similar with AI? And how can companies get ready for this? Should they prepare to just see them as costs of innovation, or how do you suggest approaching this?
It's a trickier one to tell now. So this will fall more to my intuition with it, where in those two camps I talked about of these massive, trillion parameter models that you're probably not going to be running yourself. That's a path that I think is actually fairly challenging. You will drive costs down just with sheer scale on it. But in let's call it the open model, Hugging Face, specializing side of the world, in the last few months even, these have been optimized down to the point where I can run them on my laptop. That's always for me like a spark of innovation. Like when you can go start putting this stuff on your home machine. I was in the airport in Canada downloading Llama 2 models and working with them on the plane with no Wi-Fi connection on the way home. And that really starts to be able to drive innovation. At the same point, you're not talking exotic infrastructure. And so I've seen so much progress in terms of the optimization of layers, different optimization techniques, specialization of models. While you have NVIDIA that has an incredibly capable GPU offering, you have competitors like AMD that are announcing and going all in there. CPU-driven models are very capable. So I do feel like down that path of the open innovation side, your cost per query is going to continue to come down. And I believe it's going to be at a fairly rapid rate. So for us, in terms of what we plan at Red Hat, it was to make sure that I could ride that wave of innovation. Every choice we made, from picking technology layers like PyTorch for it, I wanted to be able to really benefit from that incredibly competitive market of optimization, hardware, infrastructure on it, because it lets me use private infrastructure. It lets me use anything in the public clouds for it. And it gave me more confidence, to your point, like I can get this at a cost. It might be next year. It might be 2 years out. but I believe I can get this at a cost that'll be very beneficial to us as a company. But that's one of those areas where it's like you have to know the path and approach that you pick. We picked hybrid. We're a biased party. We believe in open hybrid cloud there because I want all of those resources at my disposal because it's been a critical part of my strategy. But that is one where I do feel like there is a path. And we'll see next year. I just don't know the time frame on that path, but I don't think it's a 5-year return on it. I feel like it is much closer to the year to 2-year time frame where done right, these things can be, beneficial to the bottom line of a company.
Very good. You touched on the importance of infrastructure. How important are those infrastructure decisions that organizations need to make when it comes to adopting AI, and what are the key considerations they need to take?
I think it's actually one of the most important decisions of where you plan to run long term. And at a broad brushstrokes, you have first the most effective, capable thing you can do is couple directly to NVIDIA using libraries like the CUDA libraries there. The challenge with that, for us at least, was that would lock my cost, my ability to get NVIDIA cards and infrastructure, which is at a premium right now. And so we moved up to a really capable abstraction layer called PyTorch, which can use a variety of infrastructure. So that was key for us because I wanted to play in that capable market. We use NVIDIA quite a bit. But if there are better cost alternatives on the market, I want to make sure those are an option for me. The second part, which is trickier, is every public cloud, they're going to invest quite a bit in this space. They will have an incredible training, the fine-tuning stack for it. They're going to build their own hardware and drive inference costs down. I think in areas that can be effective for companies. The challenge there is to do that well, you usually have to have all your data there. And for us, that was a tricky aspect. I want to use the public clouds for access to things like NVIDIA hardware, but I want to control my model type. I might run it in Amazon one day and Azure the next and Google the next and let them compete against each other. I have been a bit hesitant to lock into one of their stacks. I know those stacks will be good and efficient, but I know that it's in their best interest to then keep me there as well. And I think it is a very capable infrastructure market to be one click above that and let these powerhouses continue to drive down prices across each other on it. So those have been the two for us of really saying, I want to be one level above NVIDIA where I can use it, but I'm not totally locked to that. And I want to be one level above the public cloud stacks so I can use them because they can get NVIDIA hardware training runs faster than I can get them in our data centers. But I don't want to be tied into their cloud-specific tool chain. And I will be very careful on their inference stacks on that because they're all slightly different. And there are areas where I will run in them, but I want to keep those hybrid options open as well if I choose to pull things in-house or move things to partner sites or anywhere else where I don't want to be bound by that. Does that make sense? Those are sort of the...
Completely. I think this is an excellent piece of advice for anyone. Looking ahead then, what other future trends do you keep a close eye on?
Right now, probably one of the most significant, and I just don't know where this plays out, but would be, and when we talk about specialization of smaller models, we know that's happening. Do they get small enough to have a real CPU and GPU choice to it? When you do, CPU-only models, you now open up a world of hardware on ARM and other capabilities that lets you push models further and further closer to customers on it. We talked about like the factory use case or the telephone pole use case. It's tricky to put NVIDIA GPUs on a telephone pole. Like those require some real infrastructure to do. And yet a lot of these cases have ARM capable computers running with CPUs. So that trend of optimizing models, today I would say there are some cases where you optimize them and you do not get a great output. Like you've done too much rounding, the answers start coming back bad. But there are other cases where it is really surprising. You do these optimizations and they're almost lossless on it. Having that option of it might run a bit slower, but I have CPU infrastructure at my disposal, I think is a very powerful aspect. I don't know where we will land on this right now. There are several startups experimenting with this. You see this in the research communities all over. That'll almost add another ring to how far out we can push AI models on it. So that's one we watch really closely. The second one that, what Red Hat does, we sort of watch open source trends. We try to bring them in a package that enterprises can consume them, because open source tends to move very, very fast. The other one I would say is when we move past the POC phase, where an experiment worked, now we put it in production. We believe that just like you had continuous integration for development, where you don't develop things one time, you have security patches, you have features. It is a constant loop that you go through. We think AI development will be very similar to this, where your data will constantly change. You will be constantly retraining, fine-tuning. You will be constantly reconnecting this to the applications that use it. And we're watching that trend of what are the tool chains and stacks that let continuous integration work for AI, much like it worked for code on it too. Because for us, that's what will make this sustainable in the long term. So that closer to our heart, we watch this in open source. We try to pull these together in product offerings like OpenShift AI. But that's the other trend of how far do these models get out with CPU versus GPU? And then how sustainable can we make this? Can you update this 5 times a day with confidence on it? Or is it a little more fragile and brittle because you're scared of all the work that it took to deploy? And we want to get it to the former.
Very good. And then 2 questions I like to ask all my guests, because we're talking about the future of business and technology and the future overall. I'd like to know, what about the future are you most concerned about? And what about the future are you most excited about?
I'll start with the concern first. I think, and this might be showing my age on this, of when I came out of school, we really had a grasp of how every single piece worked in the stack, down to the silicon level. You could really map computing down to, like, I understand this. I can go through every single layer down to hardware and system calls and actually understand roughly how the processors work themselves. Even on traditional computing, if I look at that today, for someone new, I have kids looking at college right now. I'm like, coming out of college, it's just probably too complex to understand that. So you're working on layers that you don't understand. My own personal experience with AI, I've dug fairly deep into this, and yet there are still a lot of layers I don't understand. And I have this basis, of over 20 years of deep experience in learning and computing, and yet it's still a bit of a black box to me there. That I think is challenging. I always get concerned when you're building things on things you don't understand, can you really hit those negative outcomes of it? I think a really current one for us has been the Log4j security exploit challenge, where it seemed like every company on the planet was using this and really didn't even know where they had gotten it from, didn't know how to patch it. Those are some of those bad outcomes for us. So I am concerned about that. I don't really know how to solve that, because it is just so much like incredible math, creativity, software layers. the capabilities of hardware these days, I can't even describe what they are compared to when I was in school on it. But I'm also excited about exactly the same thing, because, when I think of the next generation coming out of school, having an idea and being able to realize that idea, from AI to software capabilities to infrastructure capabilities, there's nothing similar about that world than when I came out of school. When I came out of school, if you wanted to do something with infrastructure, you were buying 100,000 parts, because that is all you could get. These days, you have Raspberry Pis and Arduinos. You can go get any infrastructure you want at the click of a button. You don't have to deal with a lot of the toil if you learn how to use these AI models well. So that is incredibly exciting for me, because I feel like a lot of barriers that limit innovation have been removed. Balancing act, I think, for me will be the trick, the art for us, just as a culture to get through. But I think I'm more on the side of excitement. I really genuinely believe more good can come out of this, because people are creative. They do really inspirational things, and I think they have a really exciting tool set to work with these days.
Fantastic. I really enjoyed this, Matt. Thank you so much for your time today. Anyone who ever wants to re-watch or re-listen to this, simply head to my YouTube channel or my podcast. Thank you very much, Matt.
Thanks a lot, Bernard. It's good. Really good talking to you.